Hi, welcome all. Welcome back. Now I'm welcoming you all to this beautiful online platform, Unacademy. So all of you know that Unacademy is the India's largest online learning platform. Now I'm welcoming you all to this online platform, Unacademy. Okay. Now we are happy to announce that now we are going to start providing training to the students who are appearing for GATE and engineering service examinations. Okay. So by by considering all the things what is happened at outside world, by considering all these things we started this platform. So all of you know that since 1 year what happens, so we are in a pandemic, COVID pandemic. So most of the students are stopped their learning process because it is not possible to move from away from our home. So in that view, to provide a benefit to the students, we started this one. Now we are providing online training to the students who are appearing for GATE and engineering service examinations. And one more important thing, this training is provided by India's top educators who qualified IES, who qualified the GATE at all India level, top rankers from all India level. Okay, who are having a vast experience, 8 years, 10 years, 12 years experience in this GATE field. Those top educators are going to giving training to the students in online platform. Okay, now just I am introducing myself first. Myself G Venkata. I have 16 plus years of teaching experience. So far I mentored more than 60,000 students for their GATE examination. Okay, and at present I am pursuing PhD from JNTU Kakinada. My specialization is VLSI. Just before I told top educators are working on that. If you want to view the profile of educators briefly, just you can check everything in your Unacademy learning platform. First we check how to get this Unacademy learning platform in your device. Just go to Play Store, click on in that type Unacademy, just type Unacademy in that. Just by typing Unacademy on that, you will get the screen like this. This is the Unacademy learning app. In this screen, here there is an install button. Just click on this install button. By clicking on this install button, it will install the Unacademy learning app into your device. Okay, so far we observed how to get the Unacademy learning app into your device. Once it was properly installed in your device, just to open that app in your device. Once you open that app, there you can get what are the different courses available in that, and each course handled by which faculty, and what is the status of that educator, what is his qualification and where he is working, and his experience. Every credential of that faculty you can view there. Okay, now for your better understanding, just I am going to show one slide to you who are the top educators working on this. There is Tiwari sir, he is the IIT topper, and Ankit Goyal sir, he got All India first rank twice in GATE Electrical, and he was awarded by President of India gold medal in IIT Indore. Now Sanchit Jain sir, he is the top faculty for computer science and engineering. And Jaspal Singh sir, ex-IAS officer, he got All India 4th rank. See, All India 4th rank in IES, Indian Engineering Service. Okay, and here are few more faculty, top educators, few more working on this, working under Unacademy. Now, we are moving to what are the different batches and courses available from our side. Now, there is a new batch we started today, 22nd February 2021. There is a Ascend batch for GATE 2023. This is for electrical engineering. Okay, Ascend batch. Here are the top faculty: Gil sir, Praveen Kulkarni sir, Chayagi sir, Devendra Singh Negi sir, and Aditya Gupta and Rajiv Singh sir. These are the top faculty. Okay. So these are the faculty handling the subjects in this mechanical engineering. This batch started from today, 22nd February 2021. And don't forget to use my code during subscription VRAW10. By using this code, you get 10% discount. You get 10% discount. Next, there is a eval batch for GATE 2022. Now, just before we observed GATE 2023. Now this is GATE 2022 for mechanical engineering. Here are the top faculty. The same faculty who are handling the GATE 2023. The same faculty are handling GATE 2022 also. And this batch started from 22nd February 2021. And don't forget to use my code VRAW10 during subscription. By using that code VRAW10 during subscription, you get 10% discount. You get 10% discount. Next, there is a Spark batch we are going to start from 22nd February. This is only for English batches. This is an English batch. Spark batch for GATE 2022. This is for civil engineering. Okay. These are the top faculty who are working under this. Now, yeah, for mechanical department and another one, Tiwari sir, Uma Maheshwara sir, Meenu Gupta ma'am, Aman Raj sir. These are the top faculty we are starting a new batch as a mission DDR. Mission DDR. Top faculty. Just before I introduced about Tiwari sir, he is IIT topper, and Uma Maheshwara sir, the students who are from south side, he is a well-known person. He is the top faculty for mechanical. Okay, for south side students, sir is well-known person. Okay, and Meenu Gupta ma'am, Aman Raj sir, top educators. This batch started from 22nd February 2021. Okay, this is for mechanical. Now we are moving to civil engineering. There is a Ascend batch for GATE 2023. This batch started from 8th February. This is the faculty team or educators team who are handling the classes in this batch. Jaspal Singh sir, already I introduced him. Sir is All India topper, All India 4th rank he got in IES. And here are the top faculty. And we move to eval batch for GATE 2022 for civil engineering. The same team, the team which handled the GATE 2023, the same team is going to handling GATE 2022 classes also. This batch also started from 8th February 2021. Okay, and there is a eval batch for GATE 2022. Eval batch for GATE 2022. This batch started from 8th February 2021. Here are the top faculty who are working under this team. So, computer science and information technology, Sanchit Jain sir, already I introduced about sir. Sir is the one is the reputed faculty for computer science and information technology. Okay, for in GATE field. And now we move to electrical engineering. There is a new batch for Ascend for GATE 2023. This batch started from 1st February 2021. Okay, now this is electrical engineering for, and here are this is the team, total team who is going to handling the subjects in this batch. Okay, already just before I introduced Ankit Goyal sir, he got twice All India first rank, and Bhim Shankar sir, Srivatsa sir, Suresh sir, and B.V. Reddy, B. Venkata Reddy sir. Here are the top faculty, top educators who are present in this team. And you get the more information about these who are the South students. They know well known about these faculty members, these two faculty. And Hafiz sir is the ex-IS officer. Okay, see, if you take any team, the team is full of experience and top educators from IIT background, and who are gained the most prestigious awards. See, if you check the Ankit Goyal sir, he got the prestigious gold medal, President's Gold Medal from IIT. Okay, top faculty are present in each and every team. So we are forming these teams to provide an intention to provide more benefits to the students. Now I will give the information about what are the benefits we are providing, and why you have to choose the online compared to offline. I will explain the things later. Now there is a Ascend batch for GATE 2023 for electronics and communication engineering. This is the team handling the subjects in this? Same team. So for GATE 2023 for Electronics and Communication, this batch started from 1st February 2021. Next, there is a eval batch for GATE 2022 for Electrical Engineering. The same team who handled the GATE 2023, the same team is handling the GATE 2022 also. This batch started from 1st February 2021. Next, there is a eval batch for GATE 2022. This time this is for ECE, Electronics and Communication Engineering. This batch started from 1st February. And please don't forget to use my code during subscription, VRAW10. VRAW10. By using this code during subscription, you get 10% discount. Now, last but not least, we are going to moving to a chemical engineering. There is a eval batch for GATE 2022 in chemical engineering. Here are the top faculty who are handling the subjects in this chemical engineering. This batch started from 25th January 2021. And if any of your friends are doing chemical engineering, please inform them. Why? Because throughout India, if you observed, training for GATE and for chemical engineering is hardly available in 1 or 2 places. Okay, so for the students who are studying 3rd year and final year at different locations of India, for them it is not possible to move from their location to that location where training is available. In that view, we gathered the faculty who were top educators in chemical engineering, and we started a batch for chemical engineering. So please inform this one to your friends, and they must thank to Unacademy to provide such a beautiful facility to them. Okay, now just we glance what are the different engineering disciplines available for GATE and engineering service examinations from Unacademy. Mechanical engineering, electrical engineering, civil engineering, production and industrial, instrumentation engineering, computer science and IT department, chemical engineering, last but not least ECE, electronics and communication engineering. Now, there are 2 subscriptions available in Unacademy. One is the plus subscription. This is the basic plan. Plus subscription is the basic plan. And the next iconic subscription. With this iconic, we will take your GATE and engineering service examination preparation to the next level with personal coach. Just we are providing a personal coach to you. This is very, very important. We are providing personal coach to you. Personal coach to you. See, in the 2 subscriptions, there are few common things. India's best educators are going to handle your classes. There are interactive live sessions. Structured courses and PDFs are available. Okay, fine. Now live tests and quiz examinations. Here we are going to showing the difference with personal coach. Once you've written some online test, your personal coach is going to verify or analyze your test. Okay, and they will check where you are strong, where you need much preparation, where you are committing mistakes. Everything they will prepare. Based on that, they will prepare a proper study planner to you, and they will provide a sufficient study material to you, and if required, they suggest attend the classes for the following topics or following subjects, and at the same time, same thing, they will forward to the faculty who are the top faculty for that subject. They will forward the same information to that faculty. Okay, they will intimate you to attend that respective class on that particular day, on that particular time. Okay, like that, they will take complete care about you and about your academics. Okay, and during your preparation regularly, some gaps are there. They will fulfill that gaps, and they will make you as a loaded gun for the examination. That is the importance of personal coach. By these 2, any student get success in their examinations. These things are prepared from the experience of top educators who are already success in their examinations, who got top ranks. All India fourth rank IAS faculty is there. All India top rank GATE faculty is there. Other IAS faculties, IAS qualified faculties are there. Okay, GATE toppers are there. IIT toppers are there. Experienced faculties are there. From the knowledge of all these things, they frame these things where student is lagging. Generally, where the students are doing mistakes. Okay, by analyzing all these things, they provided a personal coach. They identified the importance of the personal coach and they provide that personal coach. See, getting classes online is everything nowadays. You are getting free classes. But after writing exam, analyze that, identifying your gaps, fulfilling that gaps such that we make you as a loaded gun ready to write the examination. That is the intention, our intention, to provide a personal coach. Yeah, please, my dear students, think once of it. Discuss with your parents, discuss with your friends, discuss with your faculty. Take a right decision, okay, and be at right position. Now, just we check the cost of each and every plan. Now, for plus plan, there are different subscriptions available: 1 month subscription, 3 month subscriptions, 6 month subscription, 12 month subscription. Okay, and 1.5 year subscription and 2 year subscription. For every subscription, just by using my code, you get 10% discount. Just use my code VRAW10. By using my code VRAW10, you get 10% discount. Okay. Now, as a faculty, I suggest the students to take minimum 1 year subscription. Minimum 1 year is required to completely attend all the subjects classes and properly for proper preparation of all the subjects, and to write the number of examinations in each and every as a subject wise, okay, as a topic wise, as a subject wise, as a whole. You need to write multiple number of examinations, and that examination has to be analyzed by yourself properly, and you have to identify the gaps, where the gaps are there, and to fulfill those gaps by preparing once, twice, thrice, revising the subjects, you need minimum 1 year of time. So my dear students, so I'm requesting you, please join minimum 1 year course, 1 year plan. Okay, if some of the employees and if they don't have much time, so prefer the remaining things. Okay, and please don't forget to use my code VRAW10 during subscription to get the 10% discount. Now we are moving to Iconic plan. So in Iconic plan, there are only two subscriptions, 12 month subscription and 24 month subscription. 12 months and 24 month subscription. For 12 month subscription, its cost is 50,250 rupees. By using my code during subscription 10%, VRAW10, you get it by 10% discount. That is 45,225 rupees. You observed one thing. Previous cost is 27,000 plus. That cost is just a transport charge if you are joining it outside for offline training. Throughout year to travel from your location to that point, for transport you need to spend minimum of 20,000 plus. Just by adding 3 to 4,000 to that, you get the training from your home itself. No need to move anywhere. More than that benefits you get. And by providing this much cost, 45,000, this is equal to the more or less equal to the amount what you are paying as a tuition fee to your institute. Okay, so with this amount we are providing a personal coach to you. Personal training we are going to providing. Personal coach are available. Your progress is going to be analyzed day to day. Your status, okay, your progress is reported every weekly to you. See, just verify, just think of it. Practically for a student it is not possible nowadays, because the students who are studying third year and final year, they are busy with their studying regular academic works, mini projects, main projects, seminars, okay, labs, records, observations, class notes, class assignments, like this. They are full busy with so many hectic works. At that time, is it possible to analyze the GATE exam, what they've written, online exam? Is it possible to verify that? Where they have to identify the gaps? No, not possible. And once you complete the written the examination on a particular subject after training, completion of training, okay, if you have any doubts in that subject, who is going to clarify the doubts? Faculty is not available, because once course is completed, that faculty will not attend the again classes, because faculty has to travel from long distance. Okay, so by making a phone call to that faculty, you need to get the clarify the doubts. How many doubts you can clarify like that in phone call? Now, at what time? Is faculty is busy or not? Busy or not? At that time? Think once all of this. Just joining training, attending classes is not sufficient. You need to assess your level, where you are. Okay, so much thing is there, but according to me, where is my level? My level is 30 marks, 40 marks, 60 marks, 80 marks, 90 marks. Like that, where you are. First assess that one. And try to improve your level. That is our intention to provide a personal coach. Most of the students are first, once they complete one online exam, if they got a 25 marks, 30 marks out of 100 marks, immediately they are going to underestimating themselves. And most of the students are stop their coaching, stop attending the classes from that point. Okay, they are not concentrating. So here the intention to provide that personal coach is motivate the student continuously. Okay, and level by level we need to improve the performance of the student. By improving the performance of the student gain more marks, more score. One student gain or getting more marks, then he get better rank. With that motive, we started this iconic plan. We are charging that amount what you said. We said 45,225 rupees only for that person only. Throughout the year he has to service you. Okay. And India's top educators, already they traveled the distance, they traveled the path what you are going to traveling now. They came in that through that path. They know what are the ups and downs in that path. They will guide you such that to make that path as a smooth. It is like a walk on flowers. They will make that. That much team we have. Because of that only, at this confidence, with that amount of confidence we are saying. So my dear students, please think once of it. Discuss with your friends, faculty, parents, but take a right decision. And whatever the thing is happened, your learning process should not stop. It should continue. Okay. Thank you. And don't forget to use my code VRAW10 during subscription. Now we are moving to our today's topic. Concept through problems on PN-Junction Diode. Already we completed some problems in this. Now, except that we are going to the remaining problems. Now already we solved these problems. I am skipping the problems what are solved already in previous last session. Already we solved this one also. Mid level. Okay, already we solved this one also. Yeah, now this one we need to solve. See this. A silicon PN junction. Silicon PN junction at thermal equilibrium is doped such that EFN minus EFI is 0.37 electron volts in the N region, and EFI minus EFP is 0.33 electron volts in the P region. Determine the built-in potential in volts. In volts. Sir, we know that built-in potential is nothing but we are calling it as contact potential V0. It is Vt into ln of Na into Nd by Ni square. So for better understanding purpose, what I am doing is this Ni square I am writing it as Ni into Ni. Next, it is Vt means Kt by Q into ln of Na by Ni plus ln of Nd by Ni. So we can write like this. Simple. Log AB is log A plus log B. That's it. So it is. Now I am taking 1 by Q common and taking this Q this side. It is a Q into V naught. Q into the E naught equals to Kt into ln of Na by Ni plus Kt into ln of Nd by Ni. Now we know the value of this Kt into ln of Na by Ni. From semiconductors we can write this is EFI minus EFP, which is nothing but a plus this one is Kt into ln of Nd by Ni is EFN minus EFI. And this is your Q times V naught. Now just to substitute the values. Substitute the values what they given. EFI minus EFP. EFI minus EFP given as 0.33 electron volts. 0.33 plus EFN minus EFI is 0.37. 0.37, that is 0.7 volts, 7 electron volts. Now just take Q this side. Therefore V naught is 0.7 electron volts by Q. Now it is 0.7 volts. This is the contact potential. So your option is, here is your option. Here is your option, 0.7 volts. See, if you observe one thing, just whatever the standard equation we have, Kt into Vt into ln of Na Nd by Ni square, I split it, I converted in the form of a energy level equations. Okay, this is already, here you observed or not, this is basically a problem in PN junction diode, but they given the data in terms of semiconductor topics what we discuss. Okay, so my dear students, please like that relate one topic to another topic. If any new problems you identify in the combination of the different topics, please try to work out more on that. Okay, direct formula, E value, substituting in that equation, getting the answer. Okay, for your semester examinations they may suit, but for competitive examinations they are no more suit. Hardly 1%, rarely 1% or 2% you get such type of problems. Not only this subject, in every subject. Okay, this type of model problems you need to solve. You need to concentrate on this. Next. Now see this. A PN junction. In a PN junction, the minority diffusion coefficients are 100 centimeter square per second on N side, 1 centimeter square per second on P side. So these are the diffusion coefficients. On N side, on N side minority carrier. So minority carrier on N side is, N side minority carriers are holes. Now the given dP is 100 centimeter square per second and dN is 1 centimeter square per second. That is the given data. First point. The ratio of minority carrier diffusion lengths on n side to p side. See this. Minority carrier diffusion lengths. Minority carrier on n side is hole. That means hole diffusion length is LP. Minority carrier on p side is electron. Now it is Ln. They want the ratio of this one to this one. So LP by Ln is how much? Take the carrier lifetimes to be the same on both sides. That means carrier lifetime means tau p is tau n. And we know one thing. Diffusion length L is square root of d into tau. For holes, LP equals to dp into root square root of tau p. Similarly, for electrons, ln is square root of dn into tau n. Now we need LP by Ln. Therefore, LP by Ln is square root of dp into tau p by dn into tau n. But they given clearly tau n and tau p both are equal. Now it is nothing but a square root of dp by dn. dp is 100 by 1. 100 by 1. So which is 10. Therefore, LP by Ln is 10. This is our option. Okay. This is the direct problem. Now, okay. So this problem. For a gallium arsenide PN junction, the following information is available. DE is nothing but a DN, sir. Diffusion coefficient of electrons 205 centimeter square per second, and diffusion coefficient of holes dp 9.8 centimeter square per second. Electron lifetime tau e 5 into 10 power minus 8 seconds, and tau h whole lifetime 10 power minus 8 seconds. The values are given for minority carriers, electrons on p side and holes on n side. Okay. Anyway, charge carrier data they given. And doping concentrations, Na is 5 into 10 power 16 and Nd is 10 power 16 per centimeter cube. Take temperature to be 300 Kelvin and Ni is 1.8 into 10 power 6 per centimeter cube for gallium arsenide. What is the built-in potential of the junction at equilibrium? Give your answer in volts. And what is the total diffusion length micrometer of minority carrier holes on n side? So first we need built-in potential. So we know the equation for built-in potential. Built-in potential we know VBI is nothing but a V naught, which is VT into Ln of Na into Nd by Ni square. We know that. Just substitute the values because everything they given. Vt 0.026 or 26 millivolts into Ln of Na value is 5 into 10 power 16 into Nd value 10 power 16 by Ni square 1.8 into 10 power 6 into 1.8 into 10 power 6. So here 6 it is 10 power 4. Next 5 by 1.8 5 divided by 1.8 divided by 1.8. It is 1.54. So 0.026 into Ln of 1.54 into 10 power 16 10 power 4, it is 10 power 20. Now is 0.026 into ln of 1.54, ln of 1.54, that is 0.43, plus 20 into ln of 10, 2.302, 3 approximately. Now its value is 20 into 2.3 plus 0.43 plus 0.026, that is a minute, sorry, 4.6 plus 0.43 into 0.026, that is 0.13, 0.13. Oh, sorry, change the position. Okay, sir. Now it is a 20 into 2.3 plus 0.43 into 0.026. Yeah, this is 1.2. It is 1.2 volts. That is the contact potential. So this is the answer, 1.2 volts. Okay, next, what is the diffusion length of minority carrier holes in n side? Just to previous problem. In previous problem we solved it. Diffusion length of holes is square root of dp into tau p. Substitute the values. Just dp value 9.8 into tau p is a 10 power minus 8. So square root of 9.8, it is 3.13 into 10 power minus 4 seconds, sorry, centimeters length. It is diffusion length 10 power minus 4 centimeters. Okay, so they are not in terms of micrometers. 10 power minus 4 centimeters is nothing but a 1 micrometer. 1 micrometer is 3.13. So 3.13 micrometer. This is the answer. So 3.1 is the answer. Okay. So just values we substituted in this one also. That's it. Now I am going to next problem. So the same problem, whatever the problems just before we solved, extension to that, the same data they given. Calculate the total current in the PN junction diode for a forward bias of 1 volt. If the junction cross sectional area is 10 power minus 3 centimeter square, give the current in milliamps. That we need to calculate the diode current equation. So this is the diode current. ID equals to I naught into e power Vd by eta Vt minus 1. So you can take in general eta value 1, and in this problem they given applied forward voltage Vd value is 1 volt they given. Okay, and Vt we know that 0.026. Now I naught value first we need to calculate. Okay, now I am going to calculating I naught value. So here I am going to calculating I naught value. So we have an equation for I naught, that is A into Q into dP by LP into Pn naught plus A into Q into Dn by Ln into Np naught. So we know the dP LP value just before we solve a problem. LP is the square root of dP into tau p, and Ln is square root of dn into tau n, and Pn naught value is concentration of holes in N region, that is Ni square by Nd. Similarly, Np naught, concentration of electrons in P region, Ni square by Na. Just substitute these things in this equation. Now you get the new value for I naught, that is A into Q into Ni square into 1 by Nd into square root of dp by tau p, because they given directly dp and tau p. In that terms I am going to converting this into 1 by Na into square root of Pn by tau n. Okay, now just to substitute the values. I naught equals to therefore I naught is equals to area. They given it as 10 power minus 3. So 10 power minus 3 into Q 1.6 into 10 power minus 19 into Ni square 1.8 into 10 power 6 into 1.8 into 10 power 6 into 1 by Nd. So Nd 10 power 16 into square root of dp wholes 9.8 by tau p. So tau p they given it as 10 power minus 8, 10 power minus 8 plus 1 by Na 5 into 10 power 16, 5 into 10 power 16 into square root of T 205 by 5 into 10 power minus 8, 5 into 10 power minus 8. Yeah, this is the I naught value. Just to simplify this. Now, so it is a see, it is a 3 3 6 6 12. It is a 10 power minus 7. Now by taking this one 10 power minus 4 outside, 10 power 4 minus 16, 10 power 16. Now it is here it became 10 power minus 4, it is a 10 power 12. Okay, and the remaining is okay. So one 1.6 into 1.8 into 1.8 is 5.18, 5.18 into 10 power minus 10, it is 10 power minus 22, minus 22 into square root of root 9.8, square root of 9.8, it is 3.13, 3.13 plus square root of 205 square root of 205 divided by 5, divided by 205 divided by 5, square root 205 divided by 5, square root of this 0.4 divided by 5, it is 1.28, 1.28 plus 3.13, 3.13, 4.4 into 5.18, 5.18, it is 22.84, 22.84 into 10 power minus 22 amperes. Just before so far we calculated I naught value, reverse saturation current. Okay, just use this equation, use that value now. So that is 22.84 into 10 power minus 22. Therefore ID is I naught 22.84 into 10 power minus 22 into, you can write e power Vd 1 volt by eta 1 and Vt 0.0, see Vt is 0.026, you can take it 26 millivolts or 0.026, so it is a 0.026 or 1000 by 26. So now the e power of that value is divided by 26, 38. So e power of that value is 5 into 10 power 16. This is 22.84 into 10 power 22 into 5.05 into 10 power 16, sorry, minus 22. Now 5.05 into 22.84, it is 115.34 into 10 power minus 6 amperes. So it is 115 point, sorry, they want in milliamps, so in milliamps there is a take in this one, sir, options. So we got 115 approximately microamps. So e power 1000 by 26, value is correct. 1000 divided by 26, e power of that value 5.05 into 10 power 16. Yeah, correct it is. Yeah, this is the correct answer, sir. 115 microamps ID in forward bias, because here we got a reverse saturation current, we got very small value, that's why ID also going to be a small value. Okay, so VD 1 volt itself, yeah, that is the correct. See, next one is calculate the change in diode voltage from 1 volt. What will cause an increase in the diode current? So for that, you need to apply this equation. From this we can write VD is equals to VT into ln of ID by I naught. Just by using this equation you can solve this, that's it. Okay, next one. Yeah, see this, a PN step junction diode with a contact potential 0.65 volts, contact potential V0 they given, sir, V0 0.65 volts, has a depletion width of 1 micrometer at equilibrium, depletion region width of 1 micrometer at equilibrium. The forward voltage at which this width reduces to 0.6. See, at what value of applied forward voltage it is reduces to 0.6 micrometer. Sir, under open circuit this one, okay, in reverse bias, by applying reverse voltage the width is increasing, by applying forward voltage the width is decreasing. So they applied forward voltage, now width is going to decreasing like that. Okay, now at what value of forward voltage the width is equals to 0.6 micrometers, that is the problem. See, For open circuit, we know the equation for open circuit. It is square root of 2 epsilon by q into, already we derived this one in last session, sir. 1 by Na plus 1 by Nd into V naught. In forward bias, depletion width is square root of 2 epsilon by q into 1 by Na plus 1 by Nd into V naught minus applied forward voltage Vf, where Vf is applied forward voltage. Applied forward voltage. Okay, Vf is applied forward voltage. Now take this one. From this I am writing W is square root of, just take V naught common in this, q into 1 by Na plus 1 by Nd into, taking V naught common, and it is a 1 minus Vf by V naught. So from this we can write this expression is this W value is, we can write under forward bias, this part is nothing but a W naught into 1 minus Vf by V naught whole power 1 by 2. That's it. Just a simple substitute the values. W they given 0.6 micrometers, W naught also micrometer, no need to change the units. 1 minus Vf you need to calculate by V naught 0.65 whole power 1 by 2. So this is 0.6 by 1, it is 0.6 itself. Now square on it. That is 0.36 is equals to 1 minus Vf by 0.65. Now just simplify this. So from this Vf by 0.65 is 1 minus 0.36. This is a 0.64. Now Vf is 0.64 into 0.65. That's it. That is 0.416. 0.416 volts you need to apply. By applying a forward voltage of 0.416, your PN junction diode depletion region width is reduces from 1 micrometer to 0.6 micrometers. Okay, that is the value. So we move to the next problem. Yeah, see, the resistivity of a germanium PN junction diode is 2 ohm to centimeter on P side and 1 ohm to centimeter on N side. Calculate the built-in potential. They given Ni 2.5 into 10 power 13 per centimeter cube, and mobility of electrons 800, mobility of holes 800, mobility of electrons 3800. Sir, we need to calculate built-in potential, and we know the equation of built-in potential. VBI or V naught equals to Vt into Ln of Na Nd by Ni square. We know that. Now Ni they given, no issue about this. Vt we know that default 0.026, and Na Nd we need to calculate. You calculate that from the resistivity. Now see this, the resistivity on P side rho P is 1 by sigma P, which is 1 by sigma P is Na into Q into mu P. They given it as 2 ohm to centimeter. Similarly, sigma rho n is 1 by sigma n, which is 1 by Nd into Q into mu n equals to 1 ohm to centimeter. They give it 1 ohm to centimeter. Now from this I am getting value of Na and Nd. Therefore, from this equation, from this you can write Na is 1 by 2q into mu p. Just substitute the values. 1 by 2q is 1.6 into 10 power minus 19 coulombs, and mu p is 800 they given. Just to simplify that, right, divided by 1.6 divided by 8 is 3.9 into 10 power 15 per centimeter cube. We got the Na, and from this I am going to calculating Nd. From this Nd is 1 by 2 into q into mu n. Simplify this. 1 by 2 into 1.6 into 10 power minus 19 into, instead of 800 they given it as a mobility of electrons 3800. Just get the value. Now it is, so right, divided by 1.6 divided by 38 is 8.2 into 10 power 14 per centimeter cube. This is Nd. Now take these values, substitute here, and Ni also they given. Therefore, contact potential V0 is Vt 0.026 into ln of Na 3.9 into 10 power 15 into Nd 8.2 into 10 power 14. 8.2 into 10 power 14 by Ni square 2.5 into 10 power 13 into 2.5 into 10 power 13. Just to simplify this. So therefore V0 is 0.026 into ln of 3.9 into 8.2 divided by 2.5 divided by 2.5. That is 5.1 to 5.1 into, so 13 10 power 110 is 10 square, it is 10 cube. So that is ln of 5.1. So that is 1.63. 0.026 into 1.63 plus 3 into ln of 10 is 2.3. So it is 3 into 2.3 plus 1.63 into 0.026. That is 0.22 volts. 0.22 volts. See, you observed or not, this one also they ask the contact potential, but they given the data, required data you need to extract from Na and Nd. Conductivity of N type and P type semiconductor. Okay, so like this, different concepts they are going to be interrelated. So you can expect this type model problems in your GATE examination. So we'll move to next problem. Yeah, find the barrier capacitance in picofarads. Barrier capacitance means a junction capacitance of a germanium PN junction whose area is 1 mm into 1 mm and whose space charge thickness W, sir, this is W naught they given it is a 2 into 10 power minus 4 centimeters, and area they given 1 mm by 1 mm. So convert this one also into centimeters. So that is 1 milli is 10 power minus 3, meter is 10 square, is 10 power minus 1 into 10 power minus 3 into 10 square centimeter square. Now it is 10 power minus 2 centimeter square. That's it. That is our area. And they given epsilon r also 16 for this. And we know epsilon naught value 8.854 into 10 power minus 14 farad per centimeter. So they want capacitance. So already we calculated. We know the barrier capacitance or junction capacitance is epsilon A by depletion region width W naught. Okay, now that is epsilon value 8.854 into 10 power minus 14 into 16 into area 10 power minus 2 by width is 2 into 10 power minus 4. Now it is 10 power minus 4, this is 10 power minus 12. Now 8.854, so it is a 2, it is 8 times. 8.854 into 8, so it is a 70.8. 70.8, 10 power minus 12 is picofarads. So in picofarads, junction capacitance or barrier capacitance is 70.8. That is the junction capacitance. So we move to next problem. In uniformly doped abrupt PN junction, the doping level of N side is doping level on N side, that means ND, because N side doping, ND is 4 times the doping level on P side, 4 times the doping level on P side. The ratio of depletion layer width is, depletion layer width, the ratio is, first they talked about N side, that means the depletion width on N side by P side XP naught. So we know one equation, NA into XP naught equals to ND into XN naught. Already we derived this equation. From this we can write XN naught by XP naught equals to XN naught by XP naught equals to NA by ND. So this is NA by ND value 4 times NA. 4 times NA. Both will get cancelled. Therefore it is 1 by 4, 0.25. Sir, you should be a little bit careful for this type of problems. In this option they did not given 4. If they given 4, 1 by 4, instead of taking xn naught by xp naught, xn naught by xp naught, if you take xp naught by xn naught, then it became 4 by 1. Now your answer is 4. Little bit cautious during solving this type of problems, because they did not specify the ratio of either xn by xp or xp by xn. From this data you need to get it from this one. Okay, now so next problem is in an abrupt PN junction, the doping concentration on P side and N side are NA and ND they given. The PN junction is reverse bias, okay, and the total depletion width is 3 micrometer. The depletion width on P side, sir, it is reverse bias, so depletion width they given it as 3 micrometer, and NA they given 9 into 10 power 16 per centimeter cube, and ND also they given 2.7 into 10 power 17 per centimeter cube. Okay, I'm changing this one also 10 power 16 because it is in 10 power 16. So 27 into 10 power 16 per centimeter cube. Okay, fine. Now they want extension of depletion region on P side. See, Extension of depletion region on P side is XP, which is XP is depletion with W into doping on N side ND by Na plus Nd. That's it. So we derive that equation from these two equations. W is Xp plus Xn. We know that. And Na into Xp is Nd into Xn. From these two equations, we can derive this one. Okay. Now Xp value is, W is 3 micrometer they given. I am keeping it as a micrometer itself. Nd is 27 into 10 power 16 by Na plus Nd. Na is 9 into 10 power 16 plus it is 27 into 10 power 16. Now 10 power 16 common. 9 ones, 9 3 and 9 threes. 3 by 4. So it is 3 micrometer into 3 by 4. 9 by 4 micrometers. So it is, which is 2.25 micrometers. 2.25 micrometers. So this is the option. Just whatever the equations we have directly from these two equations we derived this one. That's it. So we move to next problem. See, an ideal PN junction diode is forward biased moderately such that the applied bias is much greater than thermal voltage. Okay, whatever the applied forward bias voltage is much greater than thermal voltage. Fine. How much voltage is needed to increase the diode current by a factor of 10 at 300 Kelvin? So to increase the diode current by a factor of 10, how much voltage is required? Okay. Now, see, first I am writing the diode current equation, voltage equation. Voltage across the diode is Vt into ln of I0 by Id. Sorry, Id by I0. Id by I0. Okay, now, so here they talk about only Id and Vd. They want to increase diode current by 10 times. For that, how much voltage needed to increase? Okay, now let us first case required diode voltage is Vd1. In that case, diode current I got Id1. Next case, diode current is, this is first case. Diode current in second case is 10 times of Id1. Okay, 10 times of Id1. Okay, let us take Id1 is Id. Now Id2 is 10 times of Id. Okay, now what is the voltage required? Vd2 is how much for that? Okay, let us take this is Vd1 is so from this we can write Vd is directly proportional to ln of Id by I0. Now, so Vd1 by Vd2 equals to ln of Id1 by I0 because same diode, that's why no change in Id. So Id1 by I0 by ln of Id2 by, sorry, I'm taking Vd2 minus Vd1, sorry, no need to take division, just take subtraction is sufficient. Okay, so Vd2 minus Vd1 I am going to take it. that is Vt into Vd2 value ln of Id2 by I naught minus Vt into ln of Id1 by I naught. Okay, now so this is Vt common into ln of a minus ln of b, so it is ln of a by b, ln of Id2 by I naught by Id1 by I naught. So it is this I naught gets cancelled now, which is therefore Vt into ln of Id2 by Id1. Id1, that is Vt is 0.026 into ln of, it is 10 times ln of 10 Id by Id. Id gets cancelled, ln of Id is a 2.3, 0.026 into 2.3 volts. Now it is 0.0598 volts, which is 59.8 millivolts. So this much voltage you need to increase. Therefore, Vd2 is Vd1 plus 59.8 millivolts. So Vd1 plus approximately 60 millivolts you need to increase. By increasing a 60 millivolts of voltage, your current is increasing 10 times because it is in forward bias. Okay, so that is the answer, 60 millivolts. Yeah, here is the option, 60 millivolts. Millivolts. Okay. Yes, sir. Now we are moving to next problem. See, a P plus N junction has a built-in potential 0.8. Built-in means V naught, sir, or you can take it V by I also. It is 0.8 volts. The depletion layer width at a reverse bias of 1.2 volts is depletion layer width. Depletion layer width W is 2 micrometer at a applied reverse voltage of 1.2 volts. Let us take this is a VR1 and this is W1. For a reverse voltage of 7.2, what is the depletion layer width? W2 value is how much? Now, so we know one thing, sir. Under reverse bias, the depletion layer width is square root of 2 epsilon by Q into 1 by NA plus 1 by ND into V0 plus VR. This is the equation. Now from this, W is directly proportional to square root of V0 plus VR. Therefore, we can write W1 by W2 is square root of V0 plus VR1 by V0 plus VR2. You can write. Okay. Now, so this is square root of V0 0.8 plus it is a VR1 1.2 by 0.8 plus 7.2. Its value is square root of 4 by 8. Sorry, square root of 2 by 8. It is 1 by 4. It is 1 by 2. Finally, we need W2. Therefore, W2 is 2 times W1. So depletion width is increasing by increasing applied reverse voltage. So 2 into, they given it as a W1 value is a 2. 2 into 2, 4 micrometer. So 4 micrometer. This is the option. Option A, 4 micrometer. Okay. Okay, now so we have few more problems. Next session we continue these problems. So I'm thanking for one and all for spending your valuable time with us. Don't forget to use my code VRAW10 during subscription to get 10% discount. And please hit on bell symbol for getting notifications. Don't forget to subscribe us. And please give your valuable comments on YouTube to strengthen ourselves, and that is the boost to us. Please join our Telegram group to get the latest updates on our upcoming videos. And I'm thanking one and all for spending your valuable time with us. Thank you very much. Have a nice day.